Today we'll be learning about the simple AC generator. Let's keep in mind that the AC generator is different from the motor. Motors, they convert electrical energy to mechanical energy. Meanwhile, generators do the opposite. They convert mechanical energy to electrical energy. So a generator consists of a fixed coil between the poles of two permanent magnets. When the coil is rotated, the magnetic field through it changes, and as we have previously learned, according to Faraday's law, an induced EMF will be present. So the current then flows through the two slip rings, X and Y, as shown in the diagram, which are in sliding contact with the fixed carbon brushes P and Q. Let's now look at the voltage output of an AC generator. When the output of a generator is connected to a cathode ray oscilloscope, the graph of the induced electromotive force plotted against time is shown in the diagram to the right. When the coil is horizontal, the rate at which it is cutting the magnetic lines is the highest. Hence, the induced electromotive force is maximum, as shown in positions B and D. When the coil is vertical, the rate at which the coil is cutting the magnetic lines is the lowest. Hence, the induced electromotive force is minimum, 0, as shown in positions A, C, and A prime. You may recognize this graph here as the simple graph that we have learned about before of alternating current. Why is there a maximum and a minimum current? Well, it's like this. As we had previously learned before, there are many factors that will affect the size of the induced EMF. One of them that we'll be looking at is the angle. It's like when you're opening a door. The angle at which you pull on the door makes a difference. You would normally put your hand on the handle and you pull perpendicular to the door. That way you get the door to open easily. If you were to instead push on the lock of the door, as we see here, parallel to the door, would the door move? No, because the angle makes a difference. The angle here that is key is 90 degrees. That angle of 90 degrees makes you maximize the force. So with that same idea, when the angle of motion is 90 degrees, then the induced current will be the greatest. Keep in mind though, it's the angle of the motion, not the angle of the coil, not the coil's position that should be 90 degrees. When the coil is horizontal, its position is parallel to the magnetic field, but its motion will be perpendicular to the magnetic field. Perpendicular meaning 90 degrees. That special angle of 90 degrees is where you have the most induced current. So as we see here, when the coil is vertical, its motion will be parallel to the magnetic field. So when it is parallel, the angle between the motion and the magnetic field is 0. And so the sign of 0 is 0. But when the coil is horizontal, its motion will be vertical. And then the sign of 90 degrees, because it is now perpendicular to the magnetic field, right? The motion is perpendicular to the magnetic field. The sign of 90 degrees will be 1. So the maximum induced current is seen when the coil is horizontal, and the minimum current, 0, is when the coil is vertical. But let's distinguish again between the two. When the coil position is horizontal, it is parallel to the magnetic field, but the motion will be vertical, which is perpendicular to the magnetic field, and vice versa. Next, let's look at 4 ways that we can increase the induced EMF in an AC generator. In other words, how can we get more current from a generator? Number 1, use stronger permanent magnets. 2, increase the number of turns of the coil. 3, increase the frequency of rotation of the coil. And 4, decrease the distance between the permanent magnets and the coil. So if you use stronger magnets, you're going to get a greater current. If you have more wire turned around on the coil in the generator, you're going to get more current. If you spin it faster, right, increase the frequency of rotation, in other words, spin it faster, you're going to get more current. If you decrease the distance, what does that mean? It means bring the magnets closer to the coil. If you bring the magnets closer to the coil, you're going to get a greater induced EMF and hence more current. So that is all for today about generators.